Hello and welcome to this session on TensorFlow. Diabetic retinopathy is a condition which can lead to blindness, and it is caused, as the name suggests, due to diabetes. And there are ways to detect this early on and maybe cure it and prevent blindness. So how can we do something like that? There is research going on, and one of the techniques used is deep learning, which is a part of neural networks and which is a part of artificial intelligence. The way it works is hundreds of thousands of images known as fundus images are sent to the neural network, and the neural network is trained with this labeled information. Now these images, we know whether they are good or they are defective, or there is a disease in this eye or there is no disease. So that labeling is done. This labeled information is fed to the neural network. The neural network uses deep learning, and it will learn to detect if this from the image to find out if this disease exists, so that when a new image is fed, it will be able to identify whether the eye is healthy or diseased. So that's one of the applications of deep learning, and in today's session we are going to talk a little bit more in detail about what is deep learning, what are some of the libraries that are available to develop deep learning applications, and then we will zero in on TensorFlow. TensorFlow is one of the most popular, and it's growing in popular libraries, open source libraries for performing deep learning and AI. So we'll talk about what TensorFlow is and how to write a code in TensorFlow. The language is Python, but TensorFlow has a certain framework in which you need to write the code. So if you're writing like a regular Python program, it will not work. There's certain structure to writing a program in TensorFlow. So we will talk about that, the various elements of TensorFlow programming, and then we will discuss a little bit about one of the types of neural networks. Now there are neural networks come in different flavors, CNN and RNN and so on and so forth. So we will talk a little bit about recurrent neural networks in this tutorial, and then we will towards the end show you a small demo of how RNN can be used to do some time series analysis and do some predictions. Okay, so with that, let's get started. So what is deep learning? Deep learning is a set or a subset of machine learning. There are certain specialities, there are certain ways in which we perform the machine learning, and that's why it is called deep learning. For example, deep learning uses neural networks, and neural networks are kind of a simulation of the human brain. And deep learning also involves primarily analyzing large amounts of unstructured data compared to, let's say, traditional machine learning where we normally use structured data. So this unstructured data could be in the form of images, it could be in the form of video, it could be in the form of text. So that's what deep learning is about, and the term deep comes from the fact that your neural network can have multiple layers as shown here. That's where the term deep is coming from. So this is known as a deep neural network. Alright, so in order to develop some deep learning algorithms, or not algorithms, but in order to develop deep learning applications, there are certain libraries available to us which makes development of deep learning applications easier. And this is a kind of a list of some of the libraries. This is by no means an exhaustive list. TensorFlow is by far the most popular one, and that is what we are going to focus on in today's tutorial. But there are a few others like Torch and Theano and Keras, and Keras has actually now become a part of TensorFlow. It's now integrated with TensorFlow, and it is like considered one layer above TensorFlow, but it is also by itself a separate library. So this tutorial talk about TensorFlow. First of all, why is TensorFlow becoming so popular? Why should we use TensorFlow? One of the key things about TensorFlow is it makes it easy to develop the code. So there are a lot of APIs readily available which we can use and don't have to rewrite some of the code that otherwise would have been time consuming. And therefore it speeds up the process of modeling and training the model and so on and so forth. So that is one key component. And obviously the chances of errors in the program are also reduced, and other important aspect is it is highly scalable. So you can write your code and then make it run either on CPU or GPU and across a cluster of these systems for doing, let's say, for the training purpose. Primarily training is where a large part of the computation goes. A large amount of effort, time, energy goes into training the model, and of course you don't do it once, but you need to do multiple times because you train it, you test test it, you find there are some issues, again go back and train. So anytime you're training the model, it needs a lot of computation power, and TensorFlow actually helps in, and therefore you need distributed computing, because if you need to process large amount of data, so TensorFlow makes it easy to write the code in such a way that can be run in a distributed manner, either using CPUs or GPUs. GPUs are graphical processing units. You must have heard about them. They're becoming very popular. NVIDIA is one of the leaders in this space. So they are really very good at performing mathematical computations, because it helps in performing like matrix multiplication and so on. So GPUs play a big role in deep learning. And of course, it has integration with C++ and Python APIs. So it makes development that much faster. So what is TensorFlow? TensorFlow is an open source library. It's not a separate programming language by itself. It is a library, and you can use any of the common programming languages, and Python is by far the most common language with which TensorFlow programming is done. So you can import this TensorFlow library into your Python program, into your Python environment, and then you can do your deep learning development. And there is a certain way of doing this program, or the way it is executed. So you create first your nodes, and then it goes in a kind of a graphical execution way. So everything is a node, and the data is stored in tensors, and then there is a kind of a data flow along these tensors. So that's the reason why it is also the name comes as TensorFlow. We will talk about what are tensors and how the graph is created and so on and so forth as we move forward. So first of all, what is tensor? Tensor in TensorFlow stands for, it's a mathematical object, and you can actually store complicated data in kind of multi-dimensional arrays. So that is what is tensor all about. So this is like a place where you store your data. That's one of the simplest ways to define a tensor, and this can be in multi-dimension. So that is the more important thing. So for example, you have arrays or just vectors which are one-dimensional, but and then you have matrices which are two-dimensional, but tensors can be more than 3, 4, 5 dimensions, and therefore it really helps in keeping the data very tight in one place and then performing all your analysis around that. So this is, for example, a tensor of 5 by 4 dimension, and this is a 3 by 3 by 3 dimension, which is basically, the previous one was a 2-dimensional tensor. This is a 3-dimensional tensor, and there can be more dimensions as well. There are certain aspects, or there are certain terms of tensor. For example, what is a tensor rank? Rank is nothing but the dimension of the tensor. It starts with 0. 0 is basically a scalar, which is like, it's not a vector. It doesn't have multiple entries in it. It's a single value. So for example, s is equal to 10. This is a scalar, and this is considered to be, if you're storing it in a tensor, it is considered to have a rank of 0. Then you have a vector with a one-dimensional vector, let's say. So this is a rank of 1, which means it has a sequence of values in it. Like in this case, it is v is equal to 10, 11, 12. So this is rank 1. Then you can have two-dimensional matrix, which is supposed to be of rank 2, and then it can have rank 3, and so on and so forth. And then there can be of various data types. You can store data of various data types which are supported by tensor. For example, float 32, 64, int 8, and so on and so forth. So this is a list of data types that are supported. Then comes the graph. So what is a graph? Everything that the program that you write in TensorFlow is actually, first step is building a graph, and then you execute this graph. And therefore what happens is, you will see when we go into the code, it's not like a normal sequential code where one by one the steps are executed. No, the code is written in such a way that you first build the graph, and then you create a session and execute the graph. And what is a graph? Graph has what is known as nodes. So these nodes are operations, and remember, in TensorFlow world, everything is an operation. If you define or declare, not really declare, but if you assign a variable, create a variable rather, that is an operation. So it's not necessarily that you have to add two variables. Even if you create a variable, that is considered as an operation, and that becomes a node in your graph, right? So every time you assign a variable, it becomes a node, and then of course you perform some mathematical operation, that becomes a node, which is like you add two variables, multiply two variables, each of that becomes an operation or a node. And you start by building up these nodes, and then ultimately you execute these nodes in a graphical format. And that is basically how TensorFlow program is structured. chart. So here's one quick example. So let's say you want to perform a calculation like this, where f is equal to 5 times of a plus bc, right? So what do you have to do? First thing you need to do is have these variables a, b, and c, right? So you see here these become, or they translate into 3 nodes actually, right? So, and they are also called operations, by the way, in TensorFlow world. Just having a variable is also an operation. So you have a variable a, maybe you can have a value of 4 here, b has a value of 3, c has a value of 5, and each of these is a node within a graph. So this is the first step of building the graph. So you have your variables. Then the next step of building the graph is to do this multiplication, b into c. So that is a proper mathematical operation. So this is actually also a node. P is equal to b into c. Then the third step is you add a to bc, so which is equal to q is equal to a plus p. So this is 3, this is a 4th node, this is a 5th node. And then you multiply 5 to this, so that is another node, and then you get the result, right? So you see here there are 1, 2, 3, 4, 5, 6 nodes. So your first step you need to do when you're writing your code is actually each of these you define each node, and then as a kind of the last step you say, okay, create a session, and you say you execute this node, which in turn will go back and execute each of these nodes to get those values and so on. So that's the way the program flow happens. Now, there are certain elements of TensorFlow programming. We will talk about that. Unlike other programming languages, variables in TensorFlow are actually of 3 types. Variables are where you store your data within the program, right? You're all familiar with common term. You have variables in your program. Anything you want to store in your program, it's actually a variable. But in TensorFlow, there are 3 types, and variables is actually one of the type. What are the 3 types? You have constants, you have variables, and you have placeholders. So there are 3 types actually. Okay, so we will talk about each of them. Constants are something which you assign a value and you cannot change it during the course of your program. Okay, so this is something like the number of hours in a day, that is equal to 24, and that will never change. Something like that. It's a very quick analogy. So that is what is known as a constant. It will never change. So that if you have something like that in your program, you have to declare that as a constant and assign a value. Okay, so in this case, this is how you assign a constant. So tf.constant, and the value is 2 here, and you can optionally specify the data type. Otherwise, TensorFlow is intelligent enough to say what data type it should be, but if you want to explicitly specify, you can specify data type. So this is one way of creating a variable. Another way is this one, where you don't explicitly specify the data type. It just says 3.0. It is understood because the value you are assigning is a float. It is understood that the data type is float 32. All right, so this is constants. And now the difference between constants and variables is that these values, for example, the value of a, you cannot reassign. You cannot, throughout the course of your program, you cannot change that the a from 2 to 3 or 5 or any other value. A can have only a value of 2. Similarly, b can have only a value of 3. You cannot change that. That is a constant. Then you can create variables. So variables are like in any other programming language. We have variables. You can assign some initial value and you can keep changing as you, throughout the course of your program, you can keep changing. So, and the way you declare your variable, or you define or you create a variable, is somewhat like this: tf.variable. Now, one thing you need to observe, variable comes with a capital V, whereas constants and placeholders has a small p. This is something initially when you're starting up, this you may have some difficulty. For whatever reason, they have used something like this. But yeah, that's how it is. Just keep that in mind. You may get some error sometimes in the beginning. So variables, when you're creating, the V should be capital V. And the type of the variable can, again, you can explicitly mention, or you just give it a value and it will take the data type. Automatically it will assign the data type. So W in this case is a variable, B in this case is another variable. W has an initial value of 0.3, but then during the course of your program you can change that. You can reassign some other value. 0.3 can become 0.5. That is all possible because it is a variable. X here is a placeholder. So we'll see what is a placeholder in the next slide. So what is a placeholder? Placeholder is somewhat like a variable, but this is primarily used for getting data from outside. So that was the idea behind creating the concept of placeholders. Now, what is the difference? Typically, when you're performing a deep learning exercise, you cannot get all your data in one shot and store it in memory because that will become huge. So you typically will get your data in batches. So let's assume you want to train your model and you have 1 million images to perform this training. So one way of doing it would have been, you probably simply create a variable perhaps and load all these images into that variable, and then you analyze it. But that's not a very smart way, because if you bring all of those million images into memory, depending on, of course, the size of your hardware and so on, that might slow down, there may be performance issues and so on. So that's not very smart. So another way of doing it is, instead of getting all the million images, you get, because remember, it is not just storing the images, you need to perform training is an iterative process, and you need to put through these million images maybe another 100 times or 1000 times to train your model. So it's not just the storing of these million images, but then processing of these million images that takes up another large chunk of memory. So overall, not very smart. So they have come up with this fantastic idea of a concept of placeholder, whereby using placeholder you actually read your data in batches, and maybe out of the million images you get 1000 images at a time, process them, and then get the next 1000 and so on. So that is the idea behind the concept of placeholder. So placeholder is primarily used to what is known as feeding your model. So you read from somewhere from outside and then you feed it to your graph using this what is known as a variable name. This is a variable name. Feed underscore dict is a variable name. So when you're running the session, you specify how you want to feed the data to your session, to your model maybe, while you're training the model. So that is the concept of placeholder. Now I know even if you have a programming experience now, this can be sometimes initially especially a little difficult to understand, but when we move forward, as you see some examples, I think it will become much easier to understand how this is done. Okay, so the first thing to remember here is there are three types of storages within the TensorFlow programming. One is the constants, then we have variables, and then we have placeholders. Now what else? Then we have the other component is the session. As I said, you have now using these, you have created your graph, let's say, and once you created your graph, now you need to execute this graph. The only way to execute this graph is by calling what is known as a session and then the method called run. That's the only way to execute your graph. So that is another component here. So you create a session by, this is a variable. SESS is a variable. You can give any name here, but the method that you need to call is tf.session, and then you have an instance of a session, and then you call the run method and pass the node that you want to execute. Like in this example, let's say you want to do a calculation of c is equal to a plus b. So there are three nodes, as I explained earlier. Even a constant or a variable, everything is a node in TensorFlow. So you have a as a node, then b as a node, and both of these are constants. A has a value of 2, b has a value of 4, and then a third node is c, which is actually in real term also it is an operation, which is a mathematical operation of addition of a and b. So we have a node which is c is equal to a plus b. So that is your third node here. And then you are saying, okay, create a session. You're creating a session and you're saying run this node, because that is where you will get the results, right? So you're saying run this node. This in turn will result in executing this as well, whereby a will be created with a value of 2, b will be created with a value of 4, because these are prerequisites, and then c will be, the addition will be done, and then you get the result 6. All right, that is about session. Now let's take a simple example of a linear regression, how it works in TensorFlow. This is a small code example. So if you want to perform a linear regression where obviously the model will be y is equal to mx plus b, and with the given data you want to obviously come up with the values of m and b, which are the coefficients, right? So let's say we want to do something like this. To start with, you can use, again, we use Python here. So the traditional Python libraries like NumPy and Pandas, all of that is available to us. We can use them along with our TensorFlow library, because TensorFlow is nothing but one of the libraries. Okay, let's say we create some random data, test data or artificial data, and this is how you create linearly separated or evenly separated random values, right? Lid space is basically you create random values between 0 and 10 and 10 random values, and they are linearly or evenly distributed. That's what we are doing here. And we are adding some, to give it a little flavor of realness, we are adding some random values as well. Okay, so that is what we are doing here. So this is how the data looks, x underscore data, which is our independent variables, and similarly we are creating some random values of dependent variable as well, right? Y underscore label is our dependent variable. So if we do this and then if we plot, this is how our data looks, right? So if we did not add these randomness, then you would have actually got all the dots in a straight line. So we don't want that. So that's the reason we are adding the randomness as well. So this is how it looks. Now we want to find the best fit for this. All right. And again, some of you are not familiar with machine learning concepts of linear regression and so on. You may want to watch some of our other videos where we have created basics of machine learning and so on. The concept of linear regression, all the algorithms are explained there in detail. But very briefly here, what is a linear regression? Linear regression is the best fit. So you need to come up with an equation of a line which will basically, let's say, pass through these data points in such a way that the error is very minimal, right? So the line obviously will not pass through all the data points, but it will lie somewhere in between, and when you calculate error, it will be minimal. That's the idea of training this. Okay, so how do we do it in using TensorFlow? So we assign some variables. So m is a variable and b is another variable. Remember, this is how we create these variables, right? So tf dot variable tf, because we are creating variables, by the way, because they cannot be constants. The values cannot be fixed. And why are these values 0.39 and 0.2? Again, these are randomly generated. We just use an numpy random function and we generated this. It can be anything. Initially you can give anything. 0 also can be given, but just to keep it realistic, we actually create some random numbers and assign them those values. Okay, then we find out what is known as the cost function. What is the cost function? Cost function is nothing but the error between the actual value and the calculated value. So with the given values of x, if we feed to this model, it will calculate based on the value of m at any given point in time. It will create what is known as the predicted value, which is y underscore hat. So in this case, when the first run, it will be 0.39 into whatever is the value of x plus 0.2. Okay, and remember, these values will change. That's why I have given as variable. They will not be constant, and the whole training process is to change these values and then come up at the end with some set of values of m and b, such that if you use that in this equation of mx plus b, then the errors will be minimum. That is the idea behind linear regression. Again, this is a little difficult to explain here, but if you actually watch our video on linear regression, it will probably become more clear. So here the assumption is that you are familiar with linear regression. Okay, so the error obviously will be the difference between the calculated value and the actual value. As we all know, we square that. So this indicates a squaring of that so that the negative values don't come into play. All right. Then for training purpose, you need to use an optimizer. So what is optimizer? In our case, it is a gradient descent optimizer, and we need to specify the learning rate. So you give the learning rate as, in this case, we are giving as 0.001. Remember what we are doing here. We are just creating a node. None of these are being executed as of now. We are just creating the graph consisting of nodes. So let me go back. Here what I have done is m is created as a node, b is created as a node, and similarly here optimizer is created as a node, which I will show you a little later. And then when we say train, that is again another node, it will call this optimizer function and so on, right? So this is not directly running, but we are just creating the graph, and then this is where we will actually run that graph, and that is where the code will actually get executed. Now before that, one important thing to be remembered: in TensorFlow, whenever you create variables, you need to create a node for initializing the variables, which will be executed in this session. Okay, whatever, you can call anything here. This is just a name, but typically it would be called init, and we say tf dot global underscore variables underscore initializer. So all the variables that you would have created anywhere, they get initialized, and it is very important, and it is only for variables. Let's say in your code you only have constants and placeholders, then this line of code is not required. But if the moment you have variables, you have to include this line. Basically, what are you doing here? You're creating a node or an operation. You're not executing anything. You need to create an operation and then execute the operation within your session here. Okay, so this is something you need to remember. So you need to initialize the variables. So this is like you can write once and keep copying and pasting. That's it, right? Because you have this anytime you have variables. Now, all programs may not have variables. So there may be some in your test when you're doing some initial development. You may only do with constants and placeholders. order, then you will not need it. But anytime you have variables, you need to do. Okay. All right, good. So then the next step is to create a session. How do you create a session? This is kind of very, in a way, unique to TensorFlow. You use what is known as a with block. So we say with tf.session as ses, right? So in other words, it is somewhat saying like ses is equal to tf.session. You remember there are a couple of constructs for creating session. Like in the previous example we saw, let me go back here. So here we just directly said ses is equal to tf.session. This is one way of creating a session. But here what we need to remember is at some point, once you're finished with all the code, you need to close the session. Okay. So whereas if you're using something like this with block, you don't have to close the session, because the moment the with block gets completed, right, the session will automatically get closed. So that is the difference and the advantages and disadvantages of using a with block or not a with block. Okay. So here what we are saying is with tf.session as ses. That means it is indirectly we are saying create a session by the name sess, and as long as this with block is running, keep it active. The moment I exit this with block, you close the session, right? So you don't have to explicitly close the session. Okay. Anyway, so to start with, for beginners, just remember you just have to create a with block and then put the code within that with block and you're good. That's it. Okay. All right. So first thing is to start with the initial with block like this. This is the syntax. Then the first line of code will be to initialize the variables. Again, only if you have variables. If you don't have variables, you don't have to write these two lines of code. Okay. Then the next is you need to run this training method, right? So remember, as I said, we have created all the nodes and pretty much train was our last node, and there are all other nodes which are dependent, or rather the prerequisites, right, for train. Train is my kind of the last part of the node. So that is what I will do a run on, because that will give me the results, right? This in turn will execute the rest of the graph. So this train will go back and it will say, oh, okay, I need to do optimizer.minimize. And what is optimizer? Optimizer is gradient descent with a learning rate of 0.001. And then for doing this gradient descent, I have to use this model which is mx plus b. So I need to calculate and keep changing the values of m and b and feed the values of x and y and so on. So it's like a chain reaction that happens, and ultimately the training gets over and then you have the values of m and b. Remember, the whole exercise of actually training this is to come up with the right values of m and b. Initially we start with some random values, which is in this case 0.39 and 0.2 for m and b, but the training process, if you have done the machine learning module, you will see that training process basically involves changing these values of m and b so that the error is minimum. So at the end of this part, which is the running of the training session, you will end up with certain values of m and b. Now how do you get those values of m and b? Again, you need to run the session, and this is just a one time, and you say, okay, give me the values of m and b. Okay, so this is all, by the way, this is all within the with block. So the session is still active. Here you're saying run the training method, so it will run the training method, and the training method in turn will keep changing the m and b values based on the error that it is generating, the model is generating. And once the training is completed, and how does the system know the training is completed? We are specifying the epochs. Again, you must have done the machine learning module, so you will be familiar with epochs. Epochs are nothing but how many iterations you need to do. If you pass all the 1000 observations through the model for training, that is called one epoch. And so if you take this 1000 observations and pass it through the training model 100 times, that is 100 epochs. So that is what we are saying here. We are asking epochs is equal to 100. That means you pass this training data through our model 100 times. Once 100 times are over, it will exit. And remember, every epoch, the values of m and b will keep changing so that it is the error gets optimized or error gets reduced. So at the end of the training session, m and b values will have something different from what it has started off with. So those are the values that we will need here, which is basically m is the slope and b is the intercept. So that is the end of the training process. So we can basically display those details. And now you can use this to plot your model, the line that you got, the best fit line that you got. You can use the plot method to plot the line, best fit line. And you will see here, typically this is how it would be, right? So it is passing kind of in between all the data points, so that any point you take, if you calculate the error, it is minimal. Compared to, let's say, if the line was here, obviously many of them or most of them would have been errors and the error value would have been huge. So that's how you evaluate the results. Alright, so this is my Jupyter notebook, and whatever I've shown you in the slide about the linear regression, I will just quickly show you in the actual code as a demo. So we have seen that what we are trying to do is create a model, which is a linear regression model, and train it and then test it. So this is the first section, which is importing the required libraries. And what we're doing here, as you can see, is we have regular NumPy, and we will be using that for doing some generation of data and so on. Then we have matplotlib to plot the results, and then of course we are importing the TensorFlow, which is what we are going to use for creating this linear regression model. So as a first step, we will create some artificial data, which is basically some kind of a dummy data, and we are just using NumPy to do that, and random number generator and a linspace to create some data. So this is how our x underscore data looks, which is our independent data, and the dependent data is y underscore label, which is the label data. In other words, we can also call it as label data, and we have created that, and this is how our data looks if we plot it, x and y. If we plot it, just a quick note, this randomness I also mentioned in the slides, this random form is just added so that the data doesn't look like it is artificial, right? So right now, if you see here, now it looks pretty much like some natural data. Okay, so what do we do now? Next step is to first create some variables, which are basically for our y is equal to mx plus b equation, m and b are the variables. Now there are two ways of doing it. You could have created variables with some 0 or something, both of them being 0, because you need to start with some random value. In our case, what we are doing is we are actually generating a couple of random values, random numbers, using the NumPy random function, and we are assigning these two variables, right? So we created one value is 0.25 and another is 0.3, and since this is random, I can change this, but I will not change. Let's assume that this is 0.39, and I can actually, no, let us just change it so you are not confused, because every time you generate a random number, it can be any value. So it is 0.30 and 0.256. Alright, so I will now assign these two. I am creating these as TensorFlow variables. I hope you remember that in the slide I've shown you. These are the two variables. Then we need to create what is known as the cost function. And cost function is nothing but the difference between the generated value or the predicted value or the value created by the model and the actual value. So that is the error. That is the difference between that. And we, to avoid negative value, we do a square of that. So that's what I have shown in the slides as well. Then we have to define an optimizer. In our case, we will go for a gradient descent optimizer, and with the learning rate of 0.001. Alright, so remember all this, what we are doing is we are creating a graph. This is not yet executed in TensorFlow. We are executing in Python, of course, but from a TensorFlow perspective, it is not yet executed. Only in session it will get executed. Right now we are creating a graph. So we created the graph for the training, for optimizer, for the initialize operation. We are creating an operation or a node. Okay, now that's all. It's all done. Now we created all the nodes. We created the graph. Now we have to execute the graph. So this is how we execute the graph. We create a session using tf.session, and then we specify how many iterations or epochs, which is 100, and then we run this. We run the train node. You remember the node for train we created, which in turn will go back and assign all the variables and all that stuff. Okay, so once the training is done, it runs for 100 epochs. Then we have certain values of m and b, right? That's the whole process of training. You start off with some random values of m and b, and the training will actually change those values and come up with a particular value of m and b such that the error is minimum. So we are done with that. And now we can check the values of, okay, I think we did not run this, sorry. So we have to run this. So this is run now. So the training is done. So now we will have a value in final underscore slope, which is equal to 0.87. And then in the intercept as well, 0.83. Okay, so we got m and b that we wanted. Now we want to evaluate the result. So we want to see using our test data whether this is doing, how this is doing. So we just generate some test data as well, and this is our test data looks. And if we draw the plot of our model, this is how it looks. So pretty much expected. The line lies in between all the data points, and this is the best fit line such that the error is minimal. Alright, so let's go back to the presentation. Now let's talk a little bit about recurrent neural networks. So neural networks are of different types. We have CNN, we have RNN, ANN, so on. Now RNN is one type of neural network. RNN stands for recurrent neural network. The networks like CNN and ANN are feed-forward network, which means that the information pretty much only goes from left to right or from front to back, whichever way you call it. Whereas in case of recurrent neural network, there will be some information traveling backwards as well. So that is why it is known as a recurrent neural network. And each of these types have a specific application. So for example, convolutional neural networks or CNN are very good for doing image processing and object detection using for video and images. Whereas recurrent neural networks are pretty good for doing NLP or speech recognition and so on. Okay. So for the next few minutes, we will kind of focus on recurrent neural networks, and we will see an example of how we can use RNN to do a time series analysis. So in a typical neural network, this is how it looks, right? So where you have a neuron and then the inputs are coming to the neuron, and then you have an output which goes to other neurons in the other layers. In case of recurrent neural network, what happens is you have the inputs, let's say at a given point in time, but then a part of the previous output also gets fed in along with the inputs for the given time. Now this can be a little confusing. So let's see if we can take a little expanded view of this. So this is another view of one single neuron, which is what is known as in an unfolded manner. Okay. So if we are getting inputs or data over a period of time, then this is how the neuron will look. Remember, these are not three neurons. This is one neuron, and it is what is known as, it is shown in a unfolded way. Okay. We have unfolded this single neuron over a period of time. So at a given time, let's say t minus 1, an input of xt minus 1 is fed to the neuron, and it gets an output of yt minus 1. Then the next instant, which is xt at a time t, right? There is an input of xt, and then there is an output of yt. So this is a single neuron, but is displayed in an unfolded way. So this is like expanding it over a period of time. So let's start with this part here. This particular neuron gets an input at an instant t minus 1. Let's say time is equal to t minus 1. It gets an input of xt minus 1, and it gives an output of yt minus 1. Then when we go to the instant t, here it gets an input of xt, and it also additionally gets an input from this previous time frame t minus 1. So this yt minus 1 gets fed here, and that results in yt. All right. Then when we go to the time t plus 1, there is an input of xt minus 1 at that given time, plus the input from the previous time frame, which is a time frame of t. That also gets fed in here, and then we get an output of yt plus 1. Okay. So let me explain once again. This is a single neuron. These are not three different neurons. A single neuron seen over a period of time from t minus 1 to t plus 1. And unlike a regular feed-forward neuron, which only gets x, in this case, the input is x, and also another input which is coming from the previous time frame, and that is what this loop is. In this, on the left hand side diagram, this loop is indicating that. Okay. So on the right hand side, it is represented in an unfolded way. Okay. So the input, if we take a time frame t for example, is not only xt, which is the input, which is the normal input at the time frame t, but it is also getting an input from the previous time frame, which is this yt minus 1 is also being fed as an input. That is the key differentiator here. Okay. Similarly, at the instant t plus 1, it is getting a normal input of xt plus 1, plus this yt is actually being fed here, and then the output comes as yt plus 1. Okay. So this is the construct of a recurrent neural network. Now recurrent neural networks again can be of different subtypes. It can be one-to-one, one-to-many, many-to-one, and many-to-many, depending on what kind of application we want to use. One of the examples is like the stock price. So you're feeding, so there is only one input. Only thing is it is spread over a period of time. So you're feeding the stock price input, that is what comes here as an input, and you get an output, which is again the stock price, which is probably predicted over the next 2 days or 3 days or 10 days or whatever. So the number of outputs and inputs is the same. There is only one input, there is only one output. Only thing is it is spread over a time. So variables are not many. Then you have one to many. So there is one input, but you're expecting multiple outputs. What is an example of this? Let's say you want to caption an image. So how do you want to do that? What is the input that will go here? It's just an image, which is one input. But what is the output you're looking for? You're looking for a phrase maybe, right? Not just a word, but a phrase. So it's like cat is sitting on a mat, right? So the image is, there is only one image which consists of the cat sitting on a mat, but the output are like maybe 3 or 4 words, which is saying the cat is sitting on a mat. So this is one to many, right? Then you can have many to one. Examples of this are like you're feeding some text and you want to know the output, whether the text is what kind of sentiment is expressed by the text. It could be positive, it could be negative. So that's the output you're looking for. So you feed a large number of words, maybe the text may consist of words or lines or whatever. So that is what is the multiple inputs. But the output, all it says is the sentiment is positive. So it is just one output, or the sentiment is negative, just one output, right? So this is many to one. Then we have many to many. So what is an example of this? Let's say you want to do some translation. So how do you do a translation? You feed in a sentence maybe in a particular language, English, and then you want a sentence actually in another language. So that is like there are multiple inputs. One sentence can consist of multiple words, and the output also is a sentence consisting of multiple words. All right. So how do we implement RNN? This is an example of implementing an RNN for a particular use case. So in our particular example, we have the data about milk production over a few months, and using RNN, we want to predict, because this is time series analysis. So RNN is good to do time series analysis. So using RNN, we want to predict what will be the milk production in the future. So let us see how we can do that. I will first take you quickly through the slides, and then I will actually run this in a Jupyter notebook. The code, I will run it in the Jupyter notebook. So this is how it looks, the code looks. So while this is TensorFlow, you still use the standard Python libraries like NumPy and Pandas and even Matplotlib to do some initial processing, getting the data, processing it, cleaning it, whatever. All that can be still done within the same program. So that's what we're doing here. We're importing some libraries like NumPy and Pandas, and then we read the data file. And if we plot the data, we see here it is the data for the years 1962 to 75, and we can see that there is a certain trend, right? So this is how a typical time series data would look. Again, some of you, if you're not familiar with time series and time series analysis and so on, I would recommend you to go through some videos around that, which will make it easy to understand this. So this is how a typical time series data would look. In this case, it is nothing but there is only one variable, which is milk production, and it is spread across several years. So it's going from 1962 to 75, and that value has been plotted. So if you see, there is a certain kind of a trend here, which is basically going upwards, and there will be some seasonality. So time series data has these 3 components, right? So it will have a trend, it will have a seasonality, and then it will have some randomness. So that's what this graph is showing. And now if we want to perform analysis on this, time series analysis on this, first thing we need to do is split the data into train and test. And in this case, we will just use a straightforward method, which is taking the data for the first 13 years. So the idea here is we need to train our model, right? This is time series data. So and we want to predict for the future. So the way we need to use this is we have to take the data for a certain period of time and train our model. And then we use a part of the known data so that we can then ask our model to predict for that duration and compare it with the known information. So what do we mean by that? So here, if you see this data, I will show you in the notebook as well, Jupyter notebook as well. This this has 13 years of data. So what we are doing is we are taking the first 12 years and using that as our training set, right? So 12 years we are doing, and this has about, I think, 14 years of data. So we are taking 13 years of data for training purpose, and then we are using the last 1 year, remaining 1 year of data for testing purpose. Because here what we can do is this 1 year data, we know the values, right? Because if we want to compare the accuracy or anything like that, we need to know the values. So in this case, we know the values of this one particular year. So we will use that. But at the same time, we train the model for 13 years of data. And for the 14th year, we will ask our model to predict and then compare it with this known value so that we know how accurate our model is. I hope that makes sense. Okay. So that's what we are doing here. 156 is nothing but 12 into 13. On a monthly basis, we get the data. The next step is to scale the data. This is all regular data manipulation, data munching activity. And then you split it. You are basically assigning the train and test data to the scaled variables. And then you need to read the data in batches. So it is very important, as I mentioned earlier also, that instead of reading the entire data in one shot, you feed the data in batches. So in order to do that, we are writing a function for that. That's all we are doing here. So that is till here what we have done is regular Python programming. There is no TensorFlow as of now here. Okay, so far what we have done is preparation, data munching. Now what we are doing is actually training our model. So this is where TensorFlow now comes into picture. So we are importing, first step is to import the TensorFlow library. So this is how you do it, import TensorFlow STF. And then you can define some variables or constants, whichever way. Now here, of course, there are a couple of ways of doing it. You can create them as TensorFlow nodes, but that is a little bit of an overhead. We will just use the regular Python variables or constants. So here I am creating regular Python variables and I'm saying number of inputs is 1. So instead of hard coding, I'm just storing them as variables. So this is number of inputs is 1, number of time steps is 12, number of neurons is 100, and so on, right? And then learning rate is 0.03 and number of iterations we are saying is 4000. Then we create placeholders. Now we will be storing the independent variables in X and the dependent variables in Y, and this we will read from an external file. Remember, I told you placeholders are used for getting data from outside and then feeding it to our model. So that's the reason we have two placeholders, one for reading the X values and another for reading the Y values. In this step, we are only just creating the nodes, right? So this is just creating the graph. And similarly, we are mentioning what is the loss function and what is the optimizer and how to run the optimizer. And once that is done, you are initializing the variables and then you're creating a saver variable or a saver instance. So saver is basically nothing but in machine learning, you can train your model and you can save it for later use. So that's where the saving comes into play. We will see how to use that as well. And then the last step is to create your session and run this graph, right? So we are initializing the variables. Remember this, we run init. So which is nothing but this one. So we are initializing the variables, whatever are there. Instead of hard coding, remember in earlier case we were hard coding how many iterations. So here we are saying for the given number of iterations which are stored in this, maybe how many iterations we said is, what is the value of iterations? This is training iterations is 4000. So we specify that based on the number of training iterations. Next batch will basically fetch the data and then we run the session. We are basically saying train is the node which we will run in the session, and this will basically train our model, and this is more for printing. Every 100 times you print it. That's all. There's nothing more to it. So for example, the output would look somewhat like this. This is for 0, this for 100, next for 200, and so on. Okay, and then you save the model. You remember saver we created, so you save the model for later use. So this is our test data. Remember, we are doing this on training data, right? So once the training is done, we then try to create the inference on the test data so that we can compare how accurate this is. Right. So this is how the test set would look, and then we will basically restore this model, okay, because in the previous slide we created the model and we stored it. So now we have to restore the model and then run our test data against it and see what are the values that are predicted, what are the Y values, and then compare with X to see the accuracy. So train seed is what we are seeing here. So that is what will have the predicted values, and these predicted values, what we want to do is we want to create an additional column, because remember, we need to compare, because we want to find out the accuracy of this model. So we need to compare the predicted values with the actual value. So what we are doing here is adding another column called generated and assign a value to that. All right, so this is the result of the prediction. And then if we need to reshape, because we have to show this in the form of monthly results. So that's what we are doing here. And once we generate the results and then display it, we can actually see it month wise here, and the actual and the generated values. Okay, so we create a data frame which is a combination of the actual values and the predicted values from the test set. And then we can plot to see how the trend is. As you can see, pretty much the actual value is in blue color and the generated or predicted value, the curve is in yellow color. The trend is maintained. So it will probably, it's not 100% accurate, but the trend is maintained. All right, so let's do one thing. Let's go into the Jupyter notebook and take a look at how this works in TensorFlow environment. Actually, the code, I will walk you through the code. This is my Jupyter notebook, and the data is taken from this particular link. In case you're interested, you can download it from there. And this is the data for the years 1962 to 75. The first thing we do is import these libraries, because before we start with the actual TensorFlow activity, we need to prepare the data and so on. So for that, you can use your regular Python libraries, which are like NumPy, Pandas, and so on. So that's what we are doing here. And then we read the data using Pandas into a data frame. So this is a data frame, milk is a data frame, and we will do some quick exploratory analysis just to see how our data is looking. Initial 5 records that we'll get, 1, 2, 3, 4, 5, that is the head. So it goes from 1962 January to 1962 May. Once we rechange, or basically we need to split this into month specifically separately. So that's what we are doing here, date to time. So we kind of do a little bit of a reindexing, and then if we plot this, this is how the data look. As you can see, there is a clear upward trend, and there is some seasonality and so on. But anyway, we will not break that up into those components. We will just use RNN to predict and test. Okay, so the next thing is to check some, if we can run like an info, it will tell us what is the information about this data set. So let us just run that. Okay, so it is just telling us how many total columns and what is the size of the file and so on and so forth. Again, in case you're interested in doing some exploratory analysis. So what we'll do next is we will take the 13 years of data for our training data set. So what are we going to do now? Let me step back. So what have we seen here? We have seen that there are 168 records, so which is nothing but 14 years of data. We now have to split this into our training and test data set. So how do we do that? I think in case of time series, we cannot do it like 80-20 like we do in normal splitting in normal machine learning process. Here it is time series data. So what we are going to do is we will take out of this 14 years, we will take the first 13 years of data and we will use that for training, and then we will test it with the last, which is the 14th year data. We will use it for testing. Okay, so that's what we are going to do here. So let's split that. So training set will consist of my 156 records, which is nothing but 13 into 12, right? My 13 years of data I'm taking for training, and then my test set will consist of the bottom 12 observations, which is last 1 year of data, which is the 14th year. Okay, so that's now done. Training and test splitting is done. The next step is to do some normalizing, which is basically we'll use our scaling, rather we will use min-max scaler, and we will just scale the data. And now we do it for both test as well as train. Now we are ready to create our RNN model. But before that, one quick thing, in order to fetch the data, we have to create a function. So that's what we are doing here. We create a function called next batch, and how you want to fetch the steps, they are all defined as our constants, if you remember, and that's what this function is all about. So we define that function. We will be calling that in our training method. All right, so from here onwards up to there, we are done with the preparation of the data and whatever functions or whatever are required. From here onwards is where the TensorFlow part starts. So the first thing we do is import the TensorFlow library. Typically, this is a very standard way of importing importing the library, we say import TensorFlow as TF. Now TF is nothing but a name, so you can change it to TF1 or ABC or XYZ, whatever. So this part you can change, but by and large everybody uses this, so I would rather recommend you also use the same syntax. So you say import TensorFlow as TF, so it's very easy for others to understand as well. And then you declare or define a bunch of constants. That's what we are doing here. Like for example, the number of time steps, in this case it is 12, number of neurons, there are 100, number of outputs, it is only 1, and so on, right? And then the learning rate and all that, we are declaring or defining those variables in this particular block. Next is to create placeholders. You remember the placeholders are used for feeding the data. So we have X and Y. X is for the input, which is the independent variable, and Y is the output, which is the dependent variable. And in our case, these are not different characteristics or features, but it is the same one feature or one variable, but it is over a period of time. So that's the only difference. So that's what we are doing here. And now we need to create our network, right? The neural network. So in our case, we said we will create a RNN layer. Now there are different ways or different formats of RNN, which is probably not in scope of this module. So for now, we will just assume we are creating one RNN layer, and one type of RNN is GRU cell. So we will use GRU cell, and we use this APIs for creating our layer. So each cell will be with an output projection wrapper. There is a need for doing that. And again, the details of this we will probably do in another video where we talk in detail about RNN. So for now, we are creating a GRU cell with the wrapper, and the syntax for creating the GRU cell is like this. The number of units, which we said there should be 100 neurons. What will be the activation function? In this case, it is ReLU, and then number of outputs. In our case, it is only 1. Okay, so we create the cell here. Okay, then we got the GRU cell, and then we say what is our output, which is nothing but we get the outputs and the states and their states, and which is the way we get that is tf.nnn.dynamic_rnn. So if we call this and we pass the cell and the data, which is basically in placeholder. So again, remember, all we are doing here is we are creating just the nodes for the graph. So nothing is actually getting executed from a TensorFlow perspective. Okay. All right. So once that is done, now we need to pass this, calculate the outputs and the states using the dynamic_rnn method, and we pass the cell as a parameter and then the x values as a parameter. And if we run that, we will have the outputs and the states. And this is where we actually run the training method. So, or create, not really run the training method, but we create the nodes for the training and the optimizer. Then we have the initialization of the variables, and we save this model. We create a saver object just to save the model, because we will then restore it and run it to do our predictions. So this is what we will do here. So that is another node, and this is where we actually create a session and run the training. Okay, so let's go ahead and do that. That will take a little while because we said 4,000 iterations. So we will allow it to finish. We will probably come back once the training is completed. All right, so the training is done. Now let's go and run this on the test data. So let's just quickly take a look at the test data set. So this is our 1 year data for the year of 1975. So if we see this is from January, February, and so on. And we will pass this to our model. So what are we doing here? We are restoring the model here, for example, right? This is the path that we have given when we were saving the model. Let's go back once and show you. Let me show you where we did the saving of the model. Yes, so we saved the model here. So that again, we will restore that, and we will use that to run it on our test data and see how well it predicts. So let's go ahead and run this. And this is just 12 records, so this will not take time. Remember, I told you training is what takes a lot of time. The regular inference, this is called inference, doesn't take much time, right? So it just depends on how much data there were only 12 records here, so it was very quick. But in training, what we do, we pass this multiple times. There are iterations, 4,000 iterations we did, for example. So that takes longer. And in general, in machine learning, deep learning, training is what takes the maximum amount of time. All right, so let's go ahead and see the results. We will, in order to plot it, we will have to kind of adjust the format of the results. Otherwise, we will not be able to see it in a proper way. And then we will, so this is our, so what we have done is we created a data frame which consists of the predicted value and the actual value. So this is the data frame. So this is the actual value, this 834, 782 and so on. This is what our model has predicted. So it may not be so easy to see in a tabular format. So let's go ahead and plot it so that we can compare these two. So when we plot it, you will see that the trend is more or less maintained, right? So we go from the blue color is the actual values, and the yellow color or the orange color, whatever is it, is the one which is generated by our model. So it pretty much is following the actual trend. So not bad for such a quick iteration and training. So that is basically it on RNN. And let's go back to our presentation. Okay, so let's summarize. So what have we done so far? We talked about what is deep learning, briefly touched upon deep learning, and then we talked about what and why of TensorFlow, and what are the various other libraries other than TensorFlow for doing deep learning. And we saw a quick use case for linear regression, and then we did a quick use case for recurrent neural networks as well. So with that, I would like to conclude the session. Thank you very much for viewing this, and there are any comments or questions, please feel free to write it at the bottom. In case you want a response, you can put your email ID so that we can respond to you. All right, once again, thank you very much.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.